let us continue our discussion on cloud computing, or what we are discussing at different computing paradigms around these cloud computing concepts, right. Today we will discuss one aspect, which is coming up in a big way, is that sustainable cloud computing, right. So, we will see that what are the different aspects of this sustainable cloud computing and why it is important for consideration, right. So, as such, when we talk about sustainable computing, so what we try to mean that the computing which is sustainable considering the different application, environmental constraints, and in some cases even the social aspects also. But if we confine with our basically computing and the environmental constraints, so there are a lot of things come up, right. Especially we will see in the cloud computing that energy dissipated, that whether it is using renewable energy or not, and still giving appropriate reliability and services, those aspects will come into play. So, we will look into aspects like sustainable computing and sustainable cloud computing, and these keywords like sustainable cloud computing, cloud data centers, energy management, carbon footprint, all those things will come into play. Okay. So, let us start our discussion more specifically to sustainable cloud computing. So, what we have seen in this this era of cloud computing, or in this cloud computing paradigm, that there are service providers who have large data centers geographically spread, and they used to give virtualized services, right. It can be something at the IaaS level, infrastructure as a service, or it can be PaaS or platform as a service, software as a service, data as a service, sometimes databases as a service, and different aspects of the things, right. We have seen in length, and we are now used to those type of service enabled computing paradigm, right. So, what happens, this CSPs or the large service providers, like if you consider Amazon, Google, IBM, Microsoft Azure, and many others, right. They basically run on their large data centers, or sometimes we call it CDCs, right, cloud data centers, to support the user needs and different type of user demands, both with respect to computing, infrastructure, application, and things like that, right. So, so if we look at that, these user needs are not only ever increasing, they are having different type of nature, right. Some are peak at some places, some have peak in some other time, and there is a lot of computing requirement type of things. In order to support that, or in order to support reliably, one side what we see, that there are SLAs, like service level agreements, which need to be guaranteed, right. On other side, the cloud service providers need to minimize their energy requirements, their overall maintenance cost within the limit. So, their return on over investment is at the expected level, or it able to maintain some level, right. So, there are constraint of servicing a user community which is very demanding, and any fall in the service may be, there are penalties will be enforced. On the other hand, need to minimize this energy requirements, minimize the overall carbon footprints and things like that, right. So, the financial and carbon footprint related costs running such large infrastructure by these CSPs, cloud service providers, negatively impact the sustainability of the cloud services, right. So, what we want to do, we want to sustain this cloud computing paradigm, right. So, though positively is that more people are using or more user community, that means there is a good return on investment. On the other hand, you have a problem of huge power consumption, carbon footprint, which goes against say environmental laws, social laws and type of things. Not only that, sometimes getting that type of energy requirement at peak time may be questionable, right. Maybe there may be constraint on the things. So, those things actually negatively impact on the overall this sustainability issues, right. How long it will sustain, things like that, right. You can even think of that if you have a large if you have a system in your office or at even at home, which requires a AC environment, requires a standard power supply, this uninterrupted or very regulated power supply and things like that, or along with that network connectivity and so forth. So, in order to maintain and sustain that is a very challenging job, right. So, so we need to look at optimizing or taking care of all the different aspects. So, focus on minimizing the energy consumption and carbon footprint and ensuring reliability in the of the CDCs, right. That is one of the primary goal of means primary what we say goal of sustainable cloud computing, or that is the what is the requirements for towards going for sustainability of the cloud computing aspects, right. So, one is the definitely energy consumption and carbon footprint. In order to do this, the best way of one of means not may not be the best way, the one of the standard way is that when your say servers are less loaded, then you put them in sleep mode, right. So, when the request come, it wake up and give services, right. It wakes up and gives services. The problem is that if there are delay and things like that, it may violate the SLAs of the thing, right. And if there is a simultaneous peak of number of users or good demand, high demand for number of users, then there may be a problem in means maintaining the SLAs with the users, right. So, this type of scenarios may be need to be, it is not a straightforward solution, it need to be looked into in a much deeper fashion, right. So, so what we see, cloud computing paradigm offers on demand subscription oriented services, right, over the internet to host applications and process user workloads, right. So, what it does, it's a basically on demand and subscription oriented, right. You need to subscribe to this cloud service provider and things like that. So, ensure availability and reliability of the services, the components of cloud CDCs like such as network, storage, servers are to be made available around the clock. So, that is a requirement. So, if we see the basic core components, like definitely the computing resources is the first, other components also like network devices, storage devices, and even this environment itself like AC, power supply, all those things are to be available 24/7, right. And if all those are available at their peak performance or at their full operational way, then that may be a lot of consumption of energy, where practically in number of times there may be a lot of consumption of energy, practically no loading at that time, right. So, creating, processing, storing each bit of data also add to energy cost, right. It increases carbon footprints, and even what we say, it warm up the system, right. So, it requires some cooling things, which again its energy, right. So, like whatever we do with the processing, one is that you supply energy for the processing, and then in order to have with this this reduced form factors and huge volume of computing resources like servers, network devices, communication devices, other storage devices, and etcetera, in a very compact form, what we end up in dissipating lot of heat, right, which need to be cooled down, right. So, we put again energy there, right. So, there are a serious challenge in maintaining or sustaining this environment over large means over large or over time, right. So, to how to sustain this over time. So, this is one scenario, one projected energy consumption graph taken from this references. What is mentioned here, if you see the amount of energy consumed by these clouds data centers or CDCs is increasing regularly and expected to a something 8k terawatt hours by 2030. That is a what it is looking for, right, where it is going for. So, it is a huge requirement of energy, right. So, in order to see if it is, if we see that 2014 was near 0, that means very less such type of a wide scale cloud means environments or cloud service providers available, whereas in 2030 it may go up to 8,000 terawatts hours, right. So, there is a pretty high requirement. So, as we are mentioning, like if we look at the sustainable cloud computing, so the some of the components are consuming good amount of energy, right. Other than the servers, components like network, storage, memory, cooling systems of the CDCs are consuming huge amount of energy, right. So, other than the servers where virtual machines etcetera are hosts, right. To improve this energy efficiency, so overall energy efficiency CDC, there is a need for energy aware resource management techniques, right, for management of all resources including servers, storage, memory, cooling system in a more holistic manner, right. So, we require some of the energy management strategies or technique into the things. So, due to the underloading or overloading of the infrastructure resources, energy consumption in CDC is not efficient, right. Sometimes it is consuming energy, but you do not have client to work on it, or so you spend things without the return, right. So, you need to keep it alive, right. So, it is not efficient in and what we see that in many cases energy consumed while some resources like network, storage, memory, processors are in idle state, right. Still energy getting consumed because you cannot put them into say sleep mode or off mode and things like that, right. So, which adds to the increasing overall cost to the cloud services, like even if you see, even if you have your own system, means even we come out of this cloud paradigm and think that even if your system at home or office, it is how much amount it is being utilized, right. If you, there are several systems which are not being switched off, right. So, 24 hours it is may not be may be used for around 7, 8, 9, 10 hours, right. So, 50%, more than 50% of the time the system is in idle state, right, where neither the processor is used nor memory etcetera, nothing is used, and it is away the means it is away the power and energy, and then you pay for it, right. And not only that, not only you pay for it, it creates a requirement at the generating station to generate that part of the thing. So, in other sense the whole ecosystem is consuming more energy into the thing. So, CPCs are finding other alternative methods, specifically something what we say renewable energy sources to reduce carbon footprints of their CDCs, right. So, these cloud service providers are looking at alternative energy sources like carbon footprints and so forth to so that they can reduce the carbon footprint, right, of their data centers. So, these major players like Google, Amazon, Azure, Microsoft, IBM are all looking forward towards running data centers with renewable energy, or something which is more thing is that more popular is the hybrid, like you part of the things renewable, part of the things is generated energy things. So, what it is seen that future CDCs are required to provide cloud services with minimal with minimum emissions of carbon footprints and heat release in the form of greenhouse gas emission and type of things. So, what it is seen that increasingly these CSPs like with future data centers or CDCs, right. So, they will have need to minimize their carbon footprint and heat release. That means, what we say no, that there is a warming up or heat release from the whole process in form of greenhouse emission and things. So, now you see, to enable sustainable computing, data centers can be relocated based on very difficult task relocating data centers, because this has a huge installation overhead along with requirement like specific environment, and data center again are distributed over geographical spread, so that they do not fall in the same power supply line or in the same network or even same seismic zone type of things. So, to enable sustainable cloud computing, data centers can be relocated based on that opportunity of waste heat recovery type of things, like whatever the heat is being lost, whether you can recover and utilize something, accessibility to green resources, right, instead of all our standard energy sources, renewable energy sources and things. And also we try to make it to proximity to cooling resources, so that the cooling that after cooling that cool air, if it is passing through a long pipe and long duct, so it will basically lose its temperature, or in other sense it will, the temperature will be go on means dissipated and things like that, means actually it will go high and then the cooling effect will be reduced, right. So, it is near the cooling station. So, idea of the data centers are let it be near cooling stations, let it be near power stations, so that the overall power to be transmitted is over a less distance and things like that. Now, if we look at a big picture, or what we say that what are the different components, or what are the different modules, so to say, of a typical sustainable cloud computing platform, right. So, this is a thing which has been designed, which has been you will find in this particular reference. So, it has been taken from that reference. So, nevertheless, if we see that one is that the cloud architecture, right, which comprises of is that standard cloud model IaaS, PaaS or SaaS, right. So, these are the standard cloud models which are being which is definitely there, right. And the other three modules are, one is remote CDCs, right. So, there is a concept of remote CDC, that means the CDCs are at means at the remote locations and these data centers. There are cooling manager, right, which are taking care of the cooling aspect of the things, and there is a power manager, right. So, how much power, say starting from how much power to be over this renewable from the renewable sources, how much from the fossil fuel or the standard energy source state, what will be the switching mechanisms of the things and things like that. So, these are the 4 major component for a typical sustainable cloud computing installation, or when we have the sustainable cloud computing paradigm, or want to look into the as the aspect of sustainable cloud computing. So, what we see that conceptual model, this is the what we looked as the conceptual model. The conceptual model for sustainable cloud computing is in the form of layered architecture, right, which offers holistic management of cloud computing resources to make cloud computing more energy efficient and sustainable, right. So, what it tries to do a overall management of this cloud computing resources, so that the this overall your cloud computing paradigm is sustainable and energy efficient. So, first one I have seen that cloud architecture component divided into 3 aspects, as already we know that. So, that one is infrastructure, one is the platform, and one is the software as a service, right. So, this is one component which is the major thing for the cloud, and the other component is the cooling manager, which basically gives thermal alerts if temperature is higher than the threshold value and so forth. So, this takes care about the this cooling aspects, right. So, about the threshold value, heat controller will take an action to control the temperature and minimal impact on the performance of the CDC. So, what happened, as these CDCs are packed with servers and other components like storage, networks and other different other components. So, this if it is not properly cooled, so it there may be a chance of failure, there may be underperformance of the things, right. So, these are pretty much required, this cooling manager. So, other aspects is the power manager, which takes care of the overall management of the power. It controls the power generated from the renewable energy sources, like it may be from say sun or some other type of sources, like we can have those type of renewable sources, and fossil fuel like grid electricity and things like that, right. So, if there is execution of the deadline oriented workload, then this grid energy can be used to maintain the reliability of the cloud services, right. So, what we say, if there is a stringent requirement of the workload, so then we cannot rely, we want to rely more on the whatever energy available in a normal fashion, that through the grid and type of things, right. Whereas, if there is that no such requirement, then we can fall back to this our this renewable sources, like one may be your as we are telling that solar cells, other may be something windmill and type of things, right. So, those are all green sources, green energy sources, right. So, power distribution units is used to transfer electricity to all the things. So, what it happens is automatic transfer switch ATS be used to manage the energy coming from the both the sources, right, and power distribution unit transfer the electricity to all the CDCs in the cooling devices and things like that, right. So, remote CDCs, virtual machines and workloads can be migrated to remote CDCs to balance the load effectively, right. What happened, once you are getting more load on a particular server, you transfer the load some of the idle server, which gets some workloads, and overall this loading on that this what we say that so called parent VMs or parent servers is reduced, right. So, this balancing may help in reducing the overall power requirements. So, what we see there are issues of reliability and sustainability, right. Suppose ideally if I switch off when nobody, I do not find anybody, then switching on may take lot of time, and then we end up in losing SLAs. So, that is another problem. So, there is one consideration of energy, to reduce energy consumption of the cloud center, to reduce underloading and overloading resources, which improves the load balancing, to minimize heat concentration and dissipation of the cloud centers, right. So, these are the with the respect of the energy, to reduce the carbon footprints, to improve bandwidth and computing capacities, to improve storage management in the disk, etc. This is with respect to energy. Now, if we look at from the reliability point of view, definitely SLA violation is one of the things where the CSPs wants to avoid, to identify system failures and their reason to manage the risk, right, to protect critical information for security attacks and things, to provide secure VM migrations, like whenever you are migrating VMs, and to reduce the turn on investment. Suppose you put it on sleep and then you turn on, there are challenges, right. So, right. So, there is a balance between this energy optimization and maintaining the reliability at the basic level or above the threshold, right. So, there is a serious challenge into the thing. So, implication on reliability and sustainability. So, improve energy utilizations, which reduces electricity bills, operational costs, right. So, that is with respect to the lead to sustainability. So, you have a lower footprint, less bills and things. So, in order to provide reliable cloud services, the business operations of different cloud providers are replicating services which need additional resources, increase energy consumption and things like that. Now, if you have a high demand, so you have a replicated server, more replicated services, and then it increases more demand on energy. So, these are something which goes conflicting. So, we need a trade off between this energy consumption and reliability to provide cost efficient services, right. So, that there should be a trade off between the thing. So, if we look at existing energy efficient resource management techniques consume huge amount of energy while executing workloads, right, which decreases the resource release from the clouds data center. Presently or many of the data centers which are not looking at energy consumption, things like that. So, dynamic voltage and frequency scaling, as we popularly known as DVFS, based energy management techniques reduce energy consumption, but the response time and service delay due to switching of resources between high and low scaling things may affect adversely on maintaining the what we say reliability of the service or maintaining the SLA. So, what we see, the reliability of the system component is also affected by excessive turning off and turning off, right. So, if you want to turn off when it is idle state and turn on when the request is there. So, there may be a chance that you take time in turning on session and its the reliability is challenging. Power modulation decreases the reliability of server components like storage device, etc. Those are the challenges. So, by reducing energy consumption CDC, we can improve the resource utilization, reliability and performance of the servers by having appropriate mechanism of taking into the reducing the things. So, thus we see that there is a need of energy aware resource management, right. So, I am doing resource management, energy aware resource management techniques to reduce power consumption without affecting the reliability. That is the primary goal, as we were discussing that. So, that I cannot as a service provider, as a CSP, I cannot afford to have poor power management things, right, or what we, and also on the other hand I cannot afford to say violate the SLAs. So, if we look at the sustainability of the cloud computing or sustainable cloud computing, so there are several components, right. One, if you see, these are the major components, or I should say different aspects of the thing. One is the application model, right. One, that VM or virtualization issues. There are waste heat utilization, things like thermal aware scheduling, renewable energy, resource targeted energy management, right. So, energy we are managing energy, but at the resource target, it is not a general energy management. So, say if some resources idle, whether I can do more fine grain energy management and capacity planning, right. You need to plan a priori that capacity, that what you want to means based on your expected return, that how much consumption, what should be the your data center size or CDC sizes, and what will be the growth rate of the things, user demand, and accordingly the CDC, accordingly how your server provisioning, etc., to be done, right. So, those are the aspects of the things. So, what we see there are different components which plays an important role in shaping this achievement, right. So, what we discussed today, is basically looking at that in order to achieve sustainable cloud computing. So, what are the different aspects we want to look at, right. So, one is that the performance issue, like how to say support the SLAs, how to have a minimum say SLA violation, a high level of reliability while catering to the customer or the users. On the other hand, how to appropriately manage the resources in terms of energy, carbon footprint, and things like that, right. So, we need to look into this trade off between these two components, right. So, whether without compromising the reliability, how we can look into the things like this low power consumption, less carbon footprint, utilization of more energy, more renewable energy, and things like that. What we are seeing, that waste heat utilization or waste heat management, when you have your large CDCs, there are lot of heat generated which need to be managed, right. Either it should support the existing system in some time or not, in some form, or the heat need to be transferred and utilized in some other fashions, right. So, and also the thermal aware scheduling of the job. So, how suppose I have a say n number of servers, and if my workload can be run into a m number of servers, which is m is less than n, then whether it is wise to distribute the things into a into number of servers in a some particular fashion, or it is more concentrate into that minimal number of servers, so that this my consumption of energy, etc., are there. So, one is requirement of how much energy wise how you are optimized. Other requirement is that say heat generation or thermal aware scheduling of this job and workloads, and of course, on the other side is the SLAs and reliability of the service provider is there, has to be maintained, right. Okay. So, with this big picture, let us end our discussion today, and we will continue from this slide itself in our subsequent or in our next lecture, right, looking at few more aspects of this sustainable cloud computing paradigm. Thank you.